Okay, welcome to the factored form, day two. So we're gonna keep analyzing the factored form of the quadratic equation here, and but what we're gonna do today, instead of just trying to find the x-intercepts and graph properties and so forth, we are going to actually build this factored form equation given some clues that were given down here. So we'll start by analyzing the general form of the factored form of a quadratic. So you always have the y equals. The a value is the same as when you had the vertex form. So it can show you if there's a reflection, if there's a vertical stretch, vertical compression. And then the different parts here are the rest of it, where you now have factors in brackets, and the s and the t values here, when you pop them out of this equation and give it the opposite sign, these will be the x-intercepts, or what we call zeros now. Okay, so just shift that over. So knowing that, you're gonna build these equations if I give you some clues about the different parts of the quadratic. Okay. All right, so let's move on to the first example here. So you need to find the equation in factored form of the parabola that has the features. Okay, so the x-intercepts here are -2 and positive 4, and it passes through the point 1, -3. Okay, so you've seen questions like this before, where you are given clues and then you're given a point. So start assigning letters to everything. Okay, so like in our general form here, we're using s and t as our two intercepts, right? S and t. So I'm just going to label, doesn't matter which one. So I'll call this one s and I'll call that one t. Okay, so from there, then we have the other piece of information, the point. Okay, so in general, any point on a quadratic, we've always used as x and y. Okay, so now that we have the letters all laid out, we're going to go and build the equation. So write out the general form. So again, like with the vertex form before, you had to fill in A, H, and K. With the factored form, you need to fill in A, S, and T. And once you find those three letters, you can build your equation. All right, so right now we have our S and T. We need to figure out A. Okay, so you'll see when we build this equation that we need to go and solve A. Okay, so again, the S and T, it doesn't matter which way you decide to label them. If you made -2 here, T, and 4S, it would have been fine, okay? Okay, so here's the general form. I know all the letters, or most of them, so I'm just going to fill them in. So I have -3 here for Y. A, I don't know. X, we know is +1, so let's fill that right in. And then S here is -2. So see, I'm writing subtract. Then I'm going to put the -2 in for S. Okay, X is 1. Subtract T is 4. There we go. And now we're going to eventually solve for A here. But I'm just going to clean up these brackets here. So hopefully, like, you understand A times whatever's here times whatever's there, okay? So just let's clean this up. So 1 minus -2 is the same as 1 plus 2, which is 3. 1 subtract 4 is -3. Okay, and then I'm going to multiply these values up here to make it -9. But in the end, these are all still being multiplied to A. So if it really bothers you to have the 9 here, just move it so that it looks like that. Okay, so -9 times A equals -3. All right, so let's solve for A. Let's put the 9 over this way. And when we do that, okay, we get a couple negatives, and then you'll get 3 over 9, but then you want to reduce it to 1 over 3, like that. Okay, so now we have our A value, so we can now write our final factored form equation, which is, squeeze it in here. So in general, this is what it looked like. So in order to get to the factored form equation, you need to fill in A, S, and T. Okay, so let's fill those in. So you have A, or Y equals A, which is 1 over 3, X, and then we have 2 here, -2 for S. So that cleans up 2. So here, actually, I'll just write it right in. -2 like that. And then x subtract 4. Okay, so if you leave that, that's not a perfect score. I want you to clean up any signs whenever you can do that, okay? So in the end, the best answer here is to clean up and write x plus 2, x minus 4, okay? And the a value is 1/3. Okay, all right, and then again, if you double check, the x-intercepts are -2 and +4. Yes, those would pop out of here, right, if we had the factored form. So there you go, you built your first factored form equation. All right, so we'll keep going to see a few different other examples and then look at some more problems as well. Okay, so let's go on to B here. So what the clues are, so we have to build our factored form equation. The clues are the zeros are -1 and +5, and the y-intercept is -5. Okay, so let's just go through and label some things, figure them out. So we know that this one here, again, it doesn't matter which way you label it. We'll call this one S, and we'll call this one T, because those are our 2 zeros. All right, and then the y-intercept is -5. Okay, so it's different from here in a little bit. Like we were actually given a point here. Y-intercept, what is that? So if we're looking at a graph, the y-intercept of -5 is like right there on a graph, right? So if you were to actually write that as a point, that is the same as writing it 0, -5. So it didn't say it's going through this point, but it did say it went through a y-intercept, which is actually a point. So now you know your x and y value as well. So it's just go and do the same thing you did here. Okay, so I always write down the general equation. Okay, to keep the info organized, and then we start plugging stuff in that we know. So y is -5, a is the one that we need to find again, 0, x is 0, subtract s, which is -1, and so forth, okay? And then just go through the steps of cleaning it up. Okay, multiplying stuff through. Okay, so 1 times -5 is -5 times a, which is -5a, right? Boot this -5 over, and then clean it up, and you get +1. Okay, all right, so now we can write our new equation here. So y equals a, okay, and then the factored form general equation here. And then again, you were plugging in, remember, these 3 letters. Okay, if you can plug in those 3 letters, you have your equation. So y equals a, we know it, it's 1, but we don't write 1s in. Okay, x, and then we have s is -1. And then t is 5. Okay, and then yeah, just clean up any signs that are side by side like that, okay, to get a final answer like that. Okay, so there's your factored form there, and there's your factored form here. All right, okay, let's move on to the next one. Okay, so in this one here, we have some zeros. So again, just label it S and D, all right? And we have a vertex, okay? But a vertex is just a point. So it doesn't matter what term they throw at you. Hopefully you can still identify it's still a point. Okay, so again, hopefully you're, after seeing it now the 3rd time in a row, you should be able to do this really quick. Okay, so again, I recommend always writing out the general form so you get it memorized. Plug in everything you know. A we don't, X we do. All right, and then clean it up and be careful. I would say, if anything, people always make a mistake right here with these 3 terms, like, so they'll know, okay, that makes a 3, that makes a -3, but then for some reason they end up adding all of this up, and it becomes a plus 3, and it just becomes that. So just know that it's this one times this one times this one. So you should be getting, so again, if I know I skipped a step in the last one, but like if you should multiply the numbers together like that, but then you can rewrite it so that the 9 is in front, and then you're more, you're used to this form, and then you know, oh yeah, I gotta boot this over, the 9 that way, and there's your a value. okay? All right, and then you're not done. Don't stop there. Write out the actual general form now. Okay, so the general form looks like this, or the factored form. I shouldn't call it the general form. This is the general form of the factored form, but again, to fill it in with the equation, you need these 3 letters filled in. All right, so in this case here, don't forget the negative, right? And again, that negative can go to the top. It can be at the bottom. It can be right in the middle. And x subtract -2, x subtract 4. All right, and we're going to clean up the signs here to write a final answer of x plus 2, x minus 4, like that. Okay? All right, and let's go to the next one here. So again, we have some zeros. I don't know, for fun, we'll just call this one t this time and that one s, because it doesn't matter. And then we have an optimal value. All right, so you've seen these like terms like vertex and intercepts, points, right, thrown at you. You've had optimal value also thrown at you as well. Okay, so what this means here, it's either the maximum point or the minimum point on a parabola. So right now, I know we don't have a graph. We don't know which way it opens up or down, but it just means that this is the y value, right, that for the max and min. Okay, this is also the y value of the vertex. So we have the y value of the vertex here. Okay, so again, we don't know which way the graph goes. Okay, so if I made a sketch here for you, so if we, had the graph, it went this way. Oh, actually, it wouldn't go that way. It would go like this, I guess, and then like there's the optimal value, right? Or the other scenario is where, it opens up like that. So then the min value is -6. So that's what we know right now because we know the optimal value is 6. So we know the y value of the vertex. Okay, so with all the other questions that we've had here, we've always had the 2 intercepts, and then we had an actual full point. We only have half a point here. We only have the y value of the vertex point. So to find the x value, remember, the axis of symmetry, right, goes through the vertex. Okay, and the axis of symmetry, you can find it by, well, remember, it's halfway between the zeros. So like, if we, graph these two here, so it would be -4 and +4. So we don't know which way the graph goes, but we know that the x-intercepts are here. So halfway is where the axis of symmetry is. Okay, so we can find the x value of the vertex that matches here. So let's do that right now. Okay, so to find the x value of the vertex, we're going to take the intercepts, add them together, and divide by 2, because that's how we find halfway or the midpoint. So that adds to 0, and then 0 divided by 2 is 0. Okay, so the axis of symmetry is at x equals 0, but that is also the x value of the vertex. Okay, so now we have the vertex. The vertex is 0, -6. All right, and so that is our point. We have our 2 intercepts. We can build our equation. So let's build our factored form now. So we have y equals, so we're going to try to squeeze it in here in the space that we have. All right, so we have our y value, which is -6. A, we don't know. We're going to find that. Our x is 0. Our 2 intercepts were 4 and -4. Okay, clean those up. Okay, we get to there, kick that over, and it's okay if an a value ends up becoming a fraction. Just clean it up and reduce it down. So I'm seeing that the negatives here can divide away and clean up to a positive, and then I'm noticing here that I can divide a 2 out of both, so I ended up with 3/8 is my a value. All right, and then I'm going to write my final equation here by filling in my 3 letters. Okay, but I don't fill in the x and y. So my a is 3 over 8. So x minus 4, x minus -4, and then clean it up. And again, you don't have to write this step, you could just clean it up right away. But I just want to keep writing it to remind you that you cannot leave your question like that, or your final equation like that. Okay, you gotta leave it like this, clean up the sign. All right, and there is your factored form. So we're going to finish off with looking at a couple word problems here. So what we've been doing this semester so far is just we've been cycling, we've been learning the basic skills in order for us to get to the word problem. So that's why you're noticing there are a lot of word problems now, and that's what we're going to continue to do as we keep going through the last few cycles here, okay? But again, we're taking all the skills that you've picked up until now, so and that hopefully because you've seen them so many times over and over again, it's not that difficult to apply them, okay? All right, we have this arch in St. Louis here, Missouri. Okay, so it has a parabolic shape, so that means you have that parabola shape. It's a quadratic, okay? It is 192 meters from the base of the north leg to the south leg. So let's say like from here to here, from that leg to that leg, the base, it's 192 meters, okay? And the arch is 192 meters high. So again, if we're measuring how high the arch is here, okay, from the bottom to the top of it, it's 192 meters as well. Okay. All right. So I want you to determine the algebraic expression in factored form that models the shape of this arc. So again, some of you may go on and go into engineering and build bridges and arcs like this. So you need to come up with the quadratic equation that can model this structure and so forth, okay? So again, we need to build it in factored form so you can kind of, jot that down to remind yourself, okay, so I need to build this equation, I need the A, I need to find the S, and I need to find the T, okay? But, before you were given like clues directly, now it's something about this picture and so forth, so it's a little trickier. So what you can do is, to help you visualize better, you can kind of graph it on a coordinate grid. Okay, so you could just pretend like this isn't to scale, but here's the arc. Okay, from here to here, it's 192 meters. Okay, so you can think of this as like being 0, and that's 192 meters, like that. Okay, and then what else do you know? You know that the height is 192. So if we were looking at the y-axis here, so like if we went across like that, right there, that's 192 meters. Okay, so now you have it kind of on a grid, which you're used to. Okay, so from there, I need to find things like S and T, and then figure out A. So from this picture here, can you tell me what the x-intercepts are, what the zeros are? So hopefully you can see that, oh, the zeros are right here. Here's one of them, and here's the other one. Those are my zeros. Okay, that's my S and that's my T, or vice versa. So I know my S and T now. All right, so like I know those two. Okay, so from there, I need to find my A value. So again, A, it's like the vertical stretch. Okay, hopefully you can see here, it's going to be some sort of negative A value, but other than that, it's hard to determine what value of A that A will be. Okay, so we have to solve for it. But do we know some other point? Because that will help us, okay? And then we don't ever want to use a point that we're using. So we already used this point and this point. So we don't want to use those points again while we're building it, because it doesn't work, okay? So we need another point. So what's another good point that we have or we could find on this graph here? So you're looking around, like, looking up here and looking down here, you don't see anything, but you could find this one right here, right? That's the vertex. So from the information that's given to you, could you find the vertex? All right, so this one is kind of similar to that last example that we did. So we know how high the vertex went, right? So we know the y value of the vertex is 192. So we need to find the x value. And again, the vertex always goes through the axis of symmetry. So how do we find the axis of symmetry? Well, because it's halfway through, right? So what is halfway between 0 and 92? Okay, so let's find that here, and then we can go through and solve this problem. So halfway, so the axis symmetry equation would be taking the two zeros and adding them up and then dividing by 2 because you're finding the midpoint. So when you do that, you get 96. Okay, so the axis of symmetry equation is 96, but on top of it, this is the x value of the vertex. Okay, so your vertex is 96, 92. Okay, so it's like if you were down here walking along, right there is 96 meters in. Okay, go another 96 meters, you'll get to 192 meters. Okay, so that right there is 96. All the way up here is 192. So there's our vertex point. So now we could say, oh, it's 96, 192. Okay, but that is also another point on our quadratic that we can use in order to build our equation here. So like if you think about it, we have all of these letters except A. So let's go through, plug it in. So 192 is the y, x is 96. Okay, one of our zeros is 0. And the other 0, whoops, the other x value is that. The other 0 is 192. Okay, so again, the reason why they call it zeros is that that's where y is equal to 0, okay? So be able to use those terms interchangeably, zeros, x-intercepts, etc. Okay, so when we go through here and clean everything up, we're going to get those two, and then remember, you're multiplying all of these, right? So 96 times negative 96 is 9,216, but it's negative. Leave it in brackets because it's not a minus this, it's a times that. Okay, and then rearrange it like this so it's just easier to see how to solve it. Okay, so it's that times a. We're going to boot this over. Okay, and there's your a value. And I don't know, try to reduce that. And you get 1 over 48. So negative 1 over 48 when you reduce it, okay? There's your a value. All right. So then you're like, oh, that was a lot of work. I'm done. Nope. You have to write your final equation here, okay? So just, again, write out the general one to organize your thoughts here. And then fill them in, okay? So there's your a. All right, s is 96, and the other, oops, no. One of them is 0. The other one is 192. Okay, and like I said, always clean up the equation. Like if you have a 0 there, you don't need to write that. So you rewrite it as here's your a, and then here it's just x. You don't even need the brackets, but then you need the brackets for the other one. Okay, like that. I will also accept if you wanted to multiply this with the 1 here, you could write it like this as well. Okay, but leaving it 1 over 48, that's fine as well. Okay, so there is now your equation, that your quadratic equation in factored form, because it's factored, of this arc that's found in Missouri. Okay. On to this next one here. These are typical ones that they also give in the quadratic models units, where you're kicking a ball, okay, up into the air, or you shoot a rocket up into the air. It goes up and then it comes back down. So that, I guess, where it gets thrown or the path that it takes when it's flying is also quadratic as well. Okay, it makes a parabolic shape. So here is the equation. So footballs get shot in the air. Okay, the height above ground is, we're using the letter h, and here's the equation for that. H is the height, T is the time that takes place as this ball gets kicked into the air and then comes back down. Okay, so by analyzing this equation here, can you tell me what the zeros are, this relationship are, what they are, and then what they represent in this word problem? Okay, so again, let's just write out the equation here so we can break it down. Okay, so again, you are used to seeing one like this, and you know you pop out the opposite. Positive 5, right? But then what do you do out of this part here? Okay, so I'm going to show you, we're going to go fall back to our old method here. So these are both factors. So you can think of it as like that is being multiplied to this, okay? And what are we allowed to do when we're trying to find the zeros? Well, we're going to make h equal to 0, okay? So when we do that, okay, this will equal to 0. Remember what I did before with last day's lesson where we're trying to find the zeros? So like we would divide away things, like I'll just divide this away on both sides. Okay, and then see that becomes 0, and then you're left with this. Okay, and then from there you would just solve for t, and it's positive 5. Okay, so that's this part here. But then if we start it again, okay, and instead of dividing this one away, I'm going to divide this one away on both sides. Okay, so when I do that, that cancels out. This side becomes a 0, and then it's equal to this. Okay, and then from there, I want you to solve for t. Well, see, it's multiplied to t, so I need to divide it away. And then t becomes 0. Okay, so those are my two intercepts here. Okay, so again, I know that you have you're used to seeing, questions like where there's two sets of brackets with two sets of letters like that. So you just pop out, the opposite, like that one would be 1, right? And then the other one would be positive 5, right? So we would do that. But when you see one like this now, okay, so for example, it was like this, then you pop out a 5 for this one, but then this one, you just pop out 0. Okay, just make it 0. So again, you see that here, when we solved it here, it just becomes 0. Okay, so if you did another one like that, so if it was like x times x plus 4, so same thing, if you're finding the zeros, you just go, okay, pop that out the opposite, negative 4, and this one just becomes 0. Okay, so now that we've gotten our two intercepts, we still haven't finished this question here. What do they represent in the situation here? So we know h is height, t represents the time that's passed. So at time equals 0, so if we were to graph this, okay, this would be our time, and this is our height, and if we were kicking the ball, it's going up and then coming back down. Okay, so we have a time that's a 0 intercept, right, or x-intercept 0, and we have 1 at 5. So what these mean, so there and there, what do they mean in this problem? Well, you kick the ball up, and then you kick the ball came back down, all right? So these represent the time the ball was kicked and the time that the ball came back to the ground. Okay, so you can just add those in here. Okay, so I just wrote the statements here. Okay, so t equals 0. We don't just say, oh yeah, these are the zeros now. We apply it to this word problem here where a football's being kicked up and then it comes back down to the ground. So t equals 0 is the time that you kicked the ball and went up, 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 and then came down. And when it landed, it was 5 seconds, right? Yeah, 5 seconds later. And that's when the ball landed on the ground. Okay, so be able to describe what's happening in the word problem with respect to the quadratics and zeros and so forth. Okay, all right, so let's move on to the next part. So when will the football reach its maximum height? So we're looking at when, so what time would it get right to the max here? What time would that be? Okay, so just kind of analyze a sketch that we made here. So right here at the top, that's halfway, okay? So what would halfway between these two values be? That's what we need to find here. Okay, so we have, t equals 0 and we have t equals 5. Okay, so the maximum height, again, that's your vertex, right? Okay, and we know 0 and 5 here. So to find halfway, right there, that matches the vertex, we're just going to find, it's like finding the axis of symmetry equation. Okay, find the midpoint. Okay, so 2.5 seconds. Right, so, and then again, we're just making our statements here, like our therefore sentences here. So therefore, the football takes 2.5 seconds to get to the maximum height. Okay, all right, and then the next one here, what is the maximum height? So looking at this diagram here again, so we want to know how high did that ball get. Okay, so we need to figure out this value here. So again, all that is we're trying to find the vertex, right? We just found the x value. So I guess if we're trying to match the letters to the word problem, t and h, I guess. So we just found the t, that's 2.5. Okay, so at 2.5 seconds, that's where the ball will be at the highest point. So we need to figure out what the height is at that point. Okay, so we're going to do that down here by going, well, we know the time is 2.5. Okay, we know the equation, which we have right from the beginning. Okay, so negative 5t, t minus 5, like that. Okay, just double checking here. Yeah. Okay, so there's our equation. We know the time. All we do is plug it in and we'll find the height. Okay, so that t there, and then this one inside the brackets. There, and then hopefully you're comfortable with the fact that it is negative 5 times 2.5 times this value here, okay? That's what we need to do in the end. Okay, we'll just clean up that last bracket though. Okay, if we take those and subtract them, we'll get negative 2.5. All right, now we're going to multiply all those together. And we will get, so negative times negative is a positive. 31.25. We're using a word problem here, so it's okay to go to decimals. And the height is in meters. I'm just checking the units here. Meters. Okay, so what's the maximum height? Therefore, max height of the football is 31.25 meters. Okay, so just basically just doing what you've been doing with building the factored form equations, but also now, get that decimal point in there. Also now we're just, applying it to a word problem here. So we don't just say, here are the zeros, here's the vertex. We're actually saying, oh, that's the vertex is the highest point. The time it took to get to that point, is 2.5 and so forth. So we're just applying it to a word problem into the context of the problem, I guess. Okay. All right. So be able to do that and practice some of those and then try the checkpoint.